Okay, starting up at the top, switching back and forth between radical and exponential form. The top is the power, the bottom is the index. So 3 to the 1/6 power is just going to be the 6th root of 3. You could write the 6th root of 3 to the 1st, but that's a giant waste of your time because that portion of the test will be multiple choice and it will look like this, the 6th root of 3. 8 to the 1/5 power is the 5th root of 8. I'm only concerned that if they convert the base, it would be different. In this, you can convert 8 to base 2, so that would be the 5th root of 2 to the 3rd. I don't think they're going to do that, but just in case, kind of be on the lookout for that. In the next unit that we're going through, we will be converting stuff to the same base, so you might start to think about something like that. On this one, it's the square root of 51. My index is understood as 2, so that's 51 to the 1/2 power. On this one, it's the 4th root of 15 cubed, so that's 15 to the 3/4 power. This is 12 to the 2/3 power, so you look at how this 15 to the 3/4 works. That means it's going to be the cube root of 12 squared. Now, it actually doesn't matter on these if they have the cube root of 12 squared or if they have the cube root of 12 squared. Either way would be acceptable. So it might be worth checking the numerical equivalent on your calculator and making sure that those numbers come up the same. Again, the calculator will give you a garbage decimal if you type in 12 raised to the 2/3 power. 5 point blah, 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 who cares? But if I type in the cube root of 12 squared, wouldn't you know it, it's the exact same garbage decimal. So I can check for equivalency. On this one, the cube root of 37, since there's no power written on 37, that means it's 37 to the 1/3 power. C cubed to the 3/5 power, when you raise an exponent to another exponent, you multiply. That's c to the 9/5, which means it's the 5th root of c to the 9th. On number 8, I like to piece this one out. The 6 is to the 1/3 power. The x is to the 1/3 power. The y would be to the 2/3 power. If this is something like this is on the test, you might see something like that, or you might see 6x to the 1/3 power and y to the 2/3 power. Okay? Just so you know, like that means the same thing. On this over here, the 6 is to the 1/3 power, the x is to the 1/3 power, the y is to the 2/3 power. On this one, the 6 is to the 1/3 power, the x is to the 1/3 power, the y is to the 2/3 power. It does still match up. It's just how it might look a little different, multiple choice on the test. When you go to solve, we subtract 3, the square root of x is equal to 4. We square both sides, and we get x is 16. On this one, we subtract 1, and we have the square root of v, because that's what the 1/2 power is the square root, and that equals -1. You can't take the square root of something and have it equal a negative. This is an empty set. It's no solution. It doesn't work, however you want to say that. On this one, similar kind of thing. We subtract 18, That's -3 square root of y, because the 1/2 power is the same thing as the square root of y, is equal to 7. Now, you do have to be extraordinarily careful on something like this. The 3 is just a coefficient. It is not part of what's being raised to the 1/2 power. Okay? Also, don't lose that sign. When you divide by a -3, you end up with the square root of y is equal to a -7/3. That is also an empty set. It will not work. There's no solution. Nothing's going to make this be a negative number. Okay. On number 8, it kind of goes back to being normal. That'd be we square both sides. 3n plus 1 is equal to 25. Subtract 1. 3n equals 24. N is 8. Now, the square root of a negative won't work. The cube root of a negative will. So make sure you don't just throw away those answers because it doesn't look like it's going to work. If you have cube root, you sure can do a negative. And it's not going to hurt anybody's feelings. So the best thing to do on this, you can go ahead and solve through. You can try to figure it out. But you will have answers there. Try putting those answers in for x and seeing which one comes up to the correct solution. So on this one, to get rid of the cube root, we will cube. We will raise to the third power. That's 3r minus 6 is equal to 27. We add 6. That's 3r is equal to 33. So r is equal to 11. On number 14, subtract the 2 first. Square root of 3p plus 7 is equal to 4. We square both sides. That's 3p plus 7 is equal to 16. We subtract 7. That's 3p equals 9. So p is equal to 3. Be careful on ones like number 15. We're going to add 1. That's square root of k minus 4 is equal to 6. We square both sides, and we have k minus 4 is equal to 36. That means that k is going to be 40. Okay, I'm going to skip over a couple of them here. I'm not really worried about them. You've got the method here. 19 and 20, do be careful. There's variables on both sides. So you do have to square both sides. I don't know if there's going to be one on the test like we had on the practice where you had to square both sides and you got quadratics, so you had 2 answers, or you had to check for extraneous. The easiest thing to do if you feel like you're going to have to check for extraneous answers is to go ahead and maybe try to solve them by graphing. I wouldn't put my faith in numerical solve if you've been using that pretty frequently. It's not going to be as good when you have the quadratic equations, because if you're supposed to have 2 answers, it'll only ever give you 1. And solve is not reliable for something that might have more than 1 answer. Okay? Down here on the bottom, number 20, we would just square both sides. We get g plus 1 equals 2g minus 7. Subtract g from both sides. That's 1 equals g minus 7. We add 7, and we get g is equal to 8. It's important to go back and check. 8 plus 1 is going to give us 9. The square root of 9 is 3. 8 times 2 is 16 minus 7 is 9. The square root of 9 is 3. It works out. Okay? As long as we don't have like one of them that's supposed to be positive and the other one's supposed to be negative, our answer should be good there. On the back side, we're graphing. The key to graphing is really going to be, you can look at your graphing calculator, but you should be able to tell a couple of things before you get started. This is a negative on the outside, which means that our normal graph is going to get flipped upside down. Okay? Instead of being a curve like this, it's going to be a curve like this. There's a negative inside it, which means instead of going forwards, it's going to go backwards. And then we're going to be shifted a little bit off. This is actually going to be a negative 4/5 is where we'll be, is what it's shifted over, and then it's double negative, so it's just kind of like this.
Do you always know that, like, if there's a number that's negative on the inside of it goes the opposite direction, and if there's a number that's negative?
It's specifically the b value. It's specifically this one. If this one in front of the x is negative, it is going to make that flip backwards. If there's this negative that's outside, it is going to make it go upside down. So like 26, there's the negative outside, it'll be upside down. 27, there's the negative outside, it's going to be upside down. The rest of them, really, it's kind of where it is. I'm not going to be like super picky on stuff, but you have a graphing calculator. You have access to a table. You ought to be able to make a decent looking graph out of what's going on. It should be pretty accurate. This one's shifted down 9. It's still going forward, but it's upside down. So it should be something kind of like that. Oh, whoops. Sorry, down 9, not down 7. Not that. The negative 1/4 means not only is it going to be flipped upside down, it's going to be compressed. The +2 is going to move it 2 to the left. So this one is kind of like this. And then on the last one, the 2 is going to stretch it up. The 3 is going to go 3 to the right. The 1's going to go up 1. So we're 1, 2, 3 to the right. We're up 1 here. And we're stretched by a factor of 2. It's going to be more like that. Okay? Again, that's not perfect, but you will have access to your graphing calculator during the test. So I expect you to be able to do pretty well during that. Any other questions over this stuff, front or back? Something that's not making a whole lot of sense? Okay. I'm going to go ahead and stop this. I'll get this video posted later today.